Okay, so on the situations that we have two numerical variables, we said that scatter plot can save us. When there is one numerical and one categorical, we said side by side box plots would be helpful. And then the last situation when we have two categorical variables. It's a difficult situation. It's more complicated than others. Two categorical variables can be visualized by a heat map. This is a way to visualize it. And heat map is basically, it's a map that the X and Y, both of them are categorical. So Y here is cut, X is clarity. And then the boxes that we can see is, normally the numbers here is the frequency. So for instance, it is the frequency of, it is the number of diamonds that have cut equal to fair, okay, and clarity to VS1. And then the color of each of these boxes is proportional to the number. Okay, so for instance, the number here is very high, the color is hotter, and the number here is very low, so the color is colder. Okay, this is why it's called a heat map. It's very hot here, and it's very cold here. Okay, there is one complications with heat map. These numbers, in the simplest form, there are frequencies, but they can be proportions. Okay, if you divide the 170 to the total number of VS1 diamonds, then you would have the proportion of VS1 clarity that are fair. Well, their cut is fair. Or the proportion of VS1 clarity that their cut is ideal. Okay, and then we would have a different heat map. So it's important when you look at a heat map to recognize that, okay, what are these numbers? In our case, which is very simple, the numbers are frequencies. So how to comment on a heat map? To comment on a heat map, you need to comment on the variables, clarity, cut, the categories, unique categories available. So 1, 2, 3, 4, 5, 6, 7, 8 categories for clarity, 1, 2, 3, 4, 5 categories for cut. And we have 40 boxes of subcategories. And subcategories is like fair VS1 or fair SI1. Okay, this is the description, the structure, and then the hot point and the cold point. So we can see that the hottest point is here, VS2 ideal, and then also S1, SI1, and ideal. These are very hot. And the coldest place or box is here, fair and IF. In general, I1, the numbers are very low. Okay, but I don't see that much of a pattern here. So that's enough for commenting on the heat map. But heat map has a sibling. It is called bubble plot or balloon plot. It is exactly the same structure, but instead of having boxes, we have balloons. And the size of the balloon is proportional to those numbers, to the frequencies once again here. And the color is similar to the heat maps. Okay? So sometimes the balloons are better, working better than the heat map, because, well, size is also part of the story and is telling us and maybe conveying the passing the message more efficiently and effectively.